Okay, so today we're going to look at Chapter 8, which is arranging spatial data. And really, for spatial data, the type of data that you have really informs the visualization. And spatial data kind of falls into two different areas. One is geometry, which is geographic or other derived geometry data. And the other is spatial fields. So these can be scalar fields where there's one value per cell, in which case isocontours or direct volume rendering works, or you can have many values per cell, in which case you can have things like flow graphs, sparse seeds, dense seeds, or globally derived features on those. So let's take a look at some of the examples. I guess precursor is sometimes spatial information is not valuable. There's a few cases where you may have space or geographic data, but it's not necessary to understand in relation to the problem. So for example, the geographic location of horse races for Triple Crown winners, those are the Kentucky Derby, the Preakness, and the Belmont Stakes. It's not necessary to understand the fact that the horse, like Secretariat pictured here, has won the Triple Crown of horse racing. So a common source of geometry data is geographic information, and geometry data can also be derived from information on spatial fields, and cartographers need to make choices about how to derive an appropriate geometry data set from the raw data so it's suitable for all users. Here we have pictured the Johns Hopkins University dashboard for the start of the coronavirus. And here you can see almost everything was centered in China and Asia. Obviously, that's not the case now, 2 years later. There were some interesting design choices here in terms of how big they were making the circles. And in fact, as it went on for about 6 months, it ended up being like a world painted red type of thing. And so they made some design changes in how they depicted things and the size of the various marks there. So this is what it looks like in 2022. This was taken a couple days ago, and here you can see it's much more orderly, and the red dots are not as big, don't consume as much of the screen. You can see Hawaii is the little dot in the middle of the Pacific Ocean. They also have the vaccine information, which is something we didn't have 2 years ago. And they look at it over a 28-day average instead of the total number of cases. And so there's some different changes as to how they're representing that geographic information. Another example of representing geographic information is Choropleth maps. And these show a quantitative attribute encoded as color over the regions. And here we see unemployment rates in the US. The darker blues would be higher unemployment, and the lighter blues would be less unemployment. Or at least that's the way I would interpret the graph here. It may, in fact, be the opposite, but I think it's darker blue indicates more unemployment, and usually that's how the color's encoded on these. Of course, it's not just limited to geographic information, and you can have other types of geometric data. So scalar spatial fields are one of these, and these have a single value associated with each spatially defined cell. There are three major design idioms. One is isocontours, which we'll take a look at, direct volume rendering, and slicing, where you take away a dimension from the spatial data. So example of isocontours, these are topographic maps, and these are familiar to people who do a lot of hiking, or if you're exploring an area for the first time, you can see how the elevation of the area changes or goes up and down. Other examples of these types of scalar fields, you can take a slice, like A is a slice of a turbine, whereas C is the 3D volume rendering of it. And you can take a slice to take away a dimension. B is the isocontours of a tooth, and you might have seen those if you've gone to the dental office. Flexible ISO surfaces use contour trees to help users identify the structure. So the full tree that you see over on the left-hand side of this is actually quite complex, but the contour tree breaks it down and shows the connections between the various components that we have here. For multiple values, vector fields are really useful, and they have a lot of applications in physics and fluid dynamics. They can be varying over time or steady, and one of the things that you need to do with these is you need to identify if there are critical points. So the first one is a saddle, where if it approaches from left or right, it goes in, and then it goes out from that center point going up or down. The second one is a circulating source, so things originate from the green there. The next is a circulating sink, where things circle in. It's like a whirlpool, and they go into the blue dot, which is a stability point. The next two are a non-circulating source and a non-circulating sink. And there are generally about 6 choices for design idiom for vector fields. We need to consider the visual encoding and how to show it. Up to you which one you like best, but A and B are usually the worst 2 design choices. The other thing that you can do is tensor field, and these generally contain a matrix at each cell in the field, capturing more complex structure than what you can have in a vector field. These can measure things like stress, conductivity, curvature, or the ability of the region to diffuse things. And the examples that we have here are ellipsoid graphs. Okay, thanks so much for watching.